Perfect. Okay, hi everybody. Who are those Dutch carbineers? So I will go to the next slide. Like our biochar love started with Berend.
Oh, sorry. That's me. I'm so sorry.
He's a biologist and already focusing on biochars 5 years ago, and approached me about biochar. And I was studying environmental economics 2 years ago, and after 2 months, I knew for sure it would be one of the main solutions to climate change and a perfect carbon removal. And since shortly, another guy approached us, right now working at ASML, but also delivering his love for biochar. So we are now a team, but also have some interns at Dutch Carbineers and an advisory board. We first started with focusing on high tech and doing consultancy for all kinds of biochar technology producers, helping them going through their certification, finding applications for their biochar, but also helping them with finding demand for their carbon removal credits. And of course, also one of those applications was remediation. But at a certain moment, next to our consultancy, we were also quite driven to develop our own projects. And in some way, I'm not sure why, but a lot of people approached us from the global south. And if you then look at the requirements for developing such project in the global south, the opportunities are quite rare, because you need a lot of criteria to match a whole project. And in the end, high tech is the perfect way to make the most out of your biomass when it comes down to heat use, but also the efficiency, but also tracking, okay, what kind of data do we have in hand? However, it's not all the time the most effective. And if you want to do real carbon removal in the global south, you automatically come to somewhat more low tech. So that is why we decided also to develop a project in the global south. It was not only our midlife biochar crisis, but it was also because there was this new global artists ceasing standard by the Carbon Standard International that made it possible to develop projects with this low tech. And as I said already, there's a lot of biomass being wasted at the moment at the farmer sites. So that is one of the biggest reasons to start with these type of projects. But there's also a justification to do it decentralized, because there's no opportunity to bring all the biomass centralized. The whole investment environment is bad, and that, like I said already, all the criteria, like for example personnel, but also is there at least an energy grid, is there people that can operate the machine. So in the end, the only way to go at the moment is to do it with a contiki type of kiln, and Berend could explain briefly how that works.
I could and I would. Yeah, so basically how it works is that you start a small fire in the bottom of the pit. There you have your feedstock, and biogases escape, or pyrogases escape from the biomass as the heat touches the feedstock. And these pyrogases, like methane, they will roll off the side of the contiki kiln, and there they come inside of a vortex, and they touch the flame where they are burned up, and in that way the material in the bottom of the contiki kiln is protected from oxygen from the outside, and the fire that is above the biomass, it radiates heat and it carbonizes actually the material inside the contiki kiln. And in this way, you have an open pyrolysis process, and they call it flame curtain pyrolysis. The thing is, with the contiki kiln, you have to build layer after layer after layer, because every time all the pyrogases or biogases escape from the feedstock, the second term of combustion starts. And then when you wait too long and you let it burn out, when you make a campfire, for instance, everything turns to ash. And ash is not a valuable carbon storage, biochar is. So you want to build layer after layer after layer of feedstock, and eventually you extinguish it with either dust or a lid, or with water, which can be recycled. That's the explanation of how the contiki kiln works.
So that's why we came to our first project. We started this project in February this year, or January. We went to India, and we met up with our partner called Rajesh from Together for Restoration, as he has like the best knowledge regarding the methodology. We had, I think, 40 or 50 different people approaching us from the global south regarding their biomass streams, but he was the most knowledgeable regarding the methodology and had a great structure regarding his farmer groups. And we've started in Odisha and in Assam, but soon we also want to go to Maharashtra and Rajasthan. So, if I go to the next slide, so the project started, of course, with a biomass stream, and in our project in Odisha, it was rice straw, and how it looks like is that a farmer has the biomass, of course, and will bring it centralized, relatively centralized. It's still decentralized to his village, and over there's just one contiki that can pyrolyze the feedstock. However, there's a maximum, because we know exactly how many fields there are per village and how much biomass could be made into biochar. You don't want to incentivize them to use other feedstocks than the feedstock that they have in hand. Something really important regarding the biomass stream is that the reference at the moment is that it's mainly being open field burned in India. That was also one of the reasons why we went into this project, because it's the most effective way to reduce the methane emissions regarding this open field burning, but also to make their biochar with. Nevertheless, we know that in about 5 to 10 years, maybe 20 years, it's depending per region. This reference will, of course, change because infrastructure improves or agricultural practices changes. Next to our paddy straw in Odisha, we work also with corn cobs in Assam, and also sometimes when there is availability with bamboo. What we have seen is that there's a difference between those three biomass streams. Of course, paddy straw is somewhat more lighter, and you need to have a quite quick layering process. It's really labor intensive. So that might be also an improvement for a next way of doing the production, is to help the farmers to make it somewhat easier to produce the biochar with. So our project, we started with right now with 500 farmers per region. However, to give an idea about the level of scalability, we can work with 120,000 farmers within all the regions, and they can all produce 10 tons of biochar, which would mean 1.2 million tons of biochar, around 2 million tons of CO2 removal. And in future, we of course also then need to go with other waste streams, and we want to get more data about this, because if we produce with corn cobs, there will be different results than paddy straw, not only on the biochar specs, but also on the potential emissions during the production. Berend already explained about how we produce it. Something really important regarding the project is to train the people in a appropriate manner, because if they're not trained, then the quality of the project will go down. So the training is really important, and there's the trainer principle. So there's a team of 30 to 40 people that are training the farmers and are controlling the whole production system. And then, of course, the biochar application, which is really important. As there are enough cows in India, it was for us quite logical to go for manure application. And there's enough manure, so we do a 50-50 matrix, also to keep it simple for the farmers to apply it to the soil. I don't want to go too deep into the general benefits of biochar. I think quite a lot of people know it nowadays already. But maybe the most important part is that if you look at the quantitative crop yield increase, I think when Biren and I were still working in the project development and consultancy in Europe, to sell biochar, it was really difficult to not see a significant crop yield, for example, in the Netherlands. While in the global south, there are enough meta-analyses to have a crop yield increase. So I think that's really important to stretch. And then as a last thing, of course, it's a carbon sink. And how are we going to quantify it? We have established our own digital MRV model where we track all the steps of biochar production. But first of all, of course, the supervisors and the managers were registered, all the farmers and all the locations of the biochar production locations. And then there's like a 4-step approach. Of course, they will need to verify what kind of biomass they use. They take a picture of all the biomass that they wanted to use on that day. Then the second step is to make pictures of the pyrolysis. So we can give feedback when we look at the data on whether the pyrolysis is done in a proper manner. Then I think the most important part of the whole registration is the volume measurement. As we have done our lab testing, we know exactly the bulk density of the biochar. And during the biochar production, to quench it, we do it with water. And if you quench with water, of course, weight will increase. So that's not a proper measurement tool. But volume will stay the same. So we just take pictures, and right now we also ask them how many bags, but hopefully in the next stage we just need one picture, and with AI we just count the amount of bags. We'll determine the weight because we know the bulk density. And then, of course, the biochar application, we want to know for sure that they're not using it for cooking or anything else. I think it's quite difficult to do that with dry straw biochar. However, we want to see it applied. So that's also why we make a picture of the last step. And of course, the details to know for sure everything is on that time, on that location. We have also some details. But enough about the carbon removal, because we think that these projects are not only about carbon removal, which often is referred as a carbon tunnel vision. We have thought about it and have looked at all the SDG goals regarding our project and call it the Dutch Carboneers vision. And I think this is something important to stretch, because there is quite a switch in the market, not only to focus on carbon removal quantification, but also on the impact-driven projects. So yeah, like I said, at the moment, that's why this methodology is so effective. There's a lot of biomass being burned open field at the moment, and that's also what we have seen. We have seen all the smog and the smoke into the air. And these are pictures made by Berend, and yeah, it speaks for itself that it's bad for the air, for the local air, and for the climate, and we can make use out of that biomass, of course. One important part of the whole project is that this does not really only give an opportunity to do something about carbon removal, but also about the inequality in the world. I think we as a global north have a responsibility, the biggest responsibility for climate change. And I think to pay a fair amount to the global south, I think this way of incentivizing them to work against climate change and earn something on it is a proper way of doing it. And within our project, we also have focused on not to only pay the men, but also pay the women for all the work. And it's not only within the farmers that produce the biochar. No, we've decided to put them in positions all along the chain. So they can be a manager, they can be a supervisor, which I think is a great step forward, especially in this region, because we have seen the respect that they gain with these type of work. Then something quite logically, I think biochar can be a perfect way to already start fighting the drought in India, especially in Odisha. There's quite a monoculture over there. We have been there. We have seen the hectares on the horizon. We didn't see any trees. So I think biochar is now the beginning of bringing somewhat more biodiversity, at least in the soil. But in the end, we also do some plantation of bamboo and cinnamon trees to give them also some more diverse portfolio of agriculture. So then shortly, we produce the or at least the farmers are producing the biochar, putting that into the mobile application. We check and are constantly giving feedback at the moment to our team, to our supervisors, and the data that is proper, we send over to our registry or our certifying company. And if we are registered, we of course, and we are now in the last phase of our project, we need to sell. We are officially certified, but as farmers in India don't understand, okay, this is a pilot version and money will come later. They live from day to day. So for us, balancing at the moment is quite difficult when it comes down to commitment, cash flow, and communication. But if we sold something, and this has happened, that already happened the last weeks, we need to retire it, and that has also been done on the CSync registry. Shortly, if someone is interested in the things that we offer, at the moment, we just want to develop projects and to gain as much traction and to remove as much carbon as possible. So in that way, we want to be as flexible as possible when it comes down to sales, but also agreements with people that want to support our projects. I think when it comes down to our experience, from buyers, but also what we've seen by ourselves, and maybe some advice to people that want to develop these type of projects by themselves, is to first have a good look at the baseline scenario of your biomass stream, because you don't want to do more harm than good. I think it's really important to use something that at the moment has no use for them. I've put no indirect leakage on this page because if you use something that they normally use for cooking or anything else, there might be a CO2 leakage over there, or it's just a better alternative, which of course is subjective, but I should advise not to go too much into competition of biomass when it comes down to these type of biomass streams. And then you automatically come to the environmental additionality, because if the biomass was used, let's say, for example, for construction or anything else, there's not much additionality, for example, but it also needs to be financially additional. So our money that goes to the farmer at the moment, or the revenue, is like the incentive to produce biochar. Otherwise, we have seen the reference, it is being open field burned. Then an important question, do you have a justification to keep it decentralized? Because there are more efficient technologies. Like I said, it's really difficult. There are not a lot of situations where you can come up with a centralized production plant in the global south. There are opportunities, but not everywhere. So it's just important to take into consideration. Then one big, I think, elephant in the room is at the moment the methane emissions regarding biochar production. Of course, it depends on your reference scenario, but for further research, we want to have improved measurements, because right now we just take a very high number of methane emissions, but it can be specified per biomass stream, per situation. And I think it's really important to have your biochar specs as well ready to show at least a permanence to buyers. You want to have 100% transparency, no people interrupting your data. So right now we have a proper system, but we want to even further improve it. So from farmer in the end, hopefully, to a buyer, there's almost none intermediaries anymore. And of course, then in the end, it will also help to get as much revenue to the project itself or to the farmer itself. So to summarize those selective procedures or future procedures, I think it's just biomass selection, but also to look for a better MRV and also maybe tech that can provide non-methane emissions or better science. With the goal that in the below it says quantification, additionality, long-term storage, and sustainability. I've stolen it from the website of the EU, but I think those are quite good 4 pillars to stick to. And I think the last 3 we already are matching pretty good. However, quantification can be improved, and I think this is the biggest improvement that we can also gain, because buyers don't only want to see the impact, but also just want to quantify everything. So either science will need to be improved, or we have a technology that can be maybe mobile, so you have somewhat more IoT to measure stuff, or your whole MRV model is better. So then I speak about, okay, AI that will have no human errors anymore, the data directly on blockchain. And I think in the end, we need to be to work towards a better system all the time with the market and the standards, because this is a big opportunity to fight climate change. So what we've seen regarding the market at the moment, I think everybody knows it. The voluntary carbon credit market is at the moment a bit uncertainty, because there were some articles, and everybody is now having a step back and looking at all the opportunities. But that's also positive, because I see a shift going from avoidance and to somewhat maybe more shady projects to more durable and more transparent projects and CDR. What also is changing is that there are a lot of people now looking into other types of trading. So no over-the-counter trade only anymore, but also I've seen auctioning, I've seen markets based on blockchain. So I think the market will mature, and that would really bring the volumes. Like I said, I think biochar in Europe is, when it comes down to carbon removal, you can offset like one city, for example. So if we want to grow numbers, the market needs to mature, and I think we can scale rather quickly when it comes down to carbon removal. We can do 2 million tons of CO2 removal within the coming 2 or 3 years. So if the market will grow, then also the supply can come. And I think that's the last step, is to get full 100% transparency on everything. Some other shift is that it's not only anymore about carbon removal, it's also about impact driven. Also regarding claiming, there are some new regulations. And for us, a big opportunity, and I think it's also something better to always work in your own backyard first. So when it comes down to food and beverage industry, that they have a look at their own biomass streams to make biochar out of their waste streams. And we are open to work on that. And if you want to have a further look on policies, please have a look at the website of Carbon Gap. It's really good on the information that they provide. So how could you help us? If you would be interested in our carbon credits, that would really help us supporting further development of our projects, but also on all the other aspects. So if someone has ideas on production technology, on people that might want to work on MRV, or just want to work with us or for us, let us know. And in the end, like the last wording is saying work on the science that helps specifying data points. I think, Christian, you already did a wonderful job, I think several months ago, about specifying the methane emissions during a contiki type of production. I think that would gain extra trust for potential investor finance. So yeah, great to be here. And if there's any questions, please feel free to ask.
Thank you very much, Mart, for your presentation. So yes, we will actually continue the methane work. So we should have a discussion. We will start in 3 weeks or so about what feedstocks are useful in the global south, because we worked with wood chips, so it's half useful for the methane emissions. And I think you will have a technology provider already here, Paul Anderson, with his RROC kiln, which might be interesting for you, but I'm sure he will write you an email soon. And you also got a lot of questions, so we won't go through each of them, I guess. The first one from John Hoffmeyer was about your formulation. So do you mean 50-50 biochar manure by volume or by mass? And additionally, wet or dry?
Yeah, so the mixture with manure, it's not really scientifically 50-50 or no molecular base, just based on volume. They have a bucket of biochar, they have a bucket of manure, and they just mix it. The best way for mixing, it's not when it's bone dry, but it's a little bit wet, so you can it's better for practicality in mixing, but
Yeah.
it doesn't really matter in the end.
Yeah. Regarding those type of projects with farmers, you already are quite out of control. So you're already very happy if they do it in the right way, just with manure. So that's what we have seen. They have applied it with manure, but it's not a 100% for sure that they do it 50-50. It can be 40-60. But the most important step is to enrich it. And
Yes.
we hope to quantify, by the way. So this is something we want to add to our MRV model, whether we want to work together with Plant Village or other suppliers. In the end, we want to quantify the co-benefits. So not only the carbon removal, but also the application. So if we know where we apply the biochar to, we want to have one database, one bank of data where we can see, okay, this is how it affects the crop yields in the global south with only biochar and manure.
Yes, that's a complex next step, I think. But it leads to the next question. So, how much carbon content do you assume in the biochar? I assume you did your lab tests and don't test each batch. So, what's your assumption there?
Yeah, it differs per biomass waste stream. But if you look at the rice straw, you get a biochar with approximately 60 up to 61% carbon. For bamboo, that's more like 82, and wood trimming is also around 80. And corn cobs, we haven't tested yet at the moment in a lab, but from also a party that we're talking to, it's called Biochar Live. They've made biochar in an artisanal way, also from corn cobs, and they have established somewhere between 75 and 80% carbon also.
Yeah.
For corn cob biochar.
But on the safe side, they told us today 70% to use as a carbon content.
Yeah. And do you plan to have like a spot testing at some point, like just exemplary testing from time to time to see if your range is valid?
Yes, indeed. So once in a while, a sample is taken. It gets sent to a local laboratory, and they test for the carbon content, and they also test for the bulk density.
Okay. Yeah. So Johanna Dam was asking, how did producers react to the extra work? Managing time commitments, the new activities, making the char, getting it out of the pit, mixing it with manure. So if you can say something.
Yeah, I think that was quite motivating also for us when we went over. I think we were welcomed as heroes because there's something new that comes to their area, and they were really eager to do something about their soil. We've seen it; it was really dry. So that's how also the project was called: soil enrichment and preservation. But on the other hand, they were also incentivized by just a payment of producing the char. So for them, like having an extra task next to just farm with rice straw, yeah, brought a lot of eagerness to learn. It was almost like within each village also quite a respect that they were the one that were chosen to be responsible per contiki. So I think till today, of course, there are sometimes some problems on ground where people don't understand, but no major issues. And I think it really changes their lives at the moment to have some extra revenue, but also to enrich their souls.
So the last topic for is about the price and the carbon credits. So
yeah,
Core Carbon X was asking, what is the potential of carbon credits by converting 1 ton of rice straw to biochar? Or what are you internally calculating to receive?
Yeah, so 1 ton of biochar is approximately 1.75 to be on the safe side as a carbon removal potential, so tons of CO2, so 1.75 carbon credits. And the aiming price is right now 125 per carbon credit. However, the whole cost structure changes, right? If we're talking about higher volumes, because the structure with supervisors is already there, so the project can be way more efficient regarding that. So yeah, I think in the end it's more competitive than centralized biochar production, but in the end we're also talking about a different way of producing biochar. So it's a different market, but I think the price is somewhat lower than centralized biochar production when it comes down to carbon credits.
And can you bundle your certificates, or do you try to find a big off-taker more or less on the certification market, or a bigger partner, or do you try to make it step by step more or less?
Yeah, there I think there are now several options, and at the beginning the production volumes are somewhat lower. We have several potential buyers, but it would also cost our time. It would cut our time if we find one buyer, right? So we can purely focus on further project development, improving it, instead of trying to sell it to multiple parties. So there is an advantage to find one buyer, and I think for the next season we are maybe looking for somewhat more serious offtake agreements that can help us planning the whole production cycle. Right now, I think when it comes down to our own financing, it was quite unorthodox, right? We sold some credits on beforehand. We went over, certified the whole project, and now we need to sell. So every buyer is helpful for us at the moment. So there's not really a particular strategy in that. But for the next seasons, I would prefer to find long-term offtake agreements to get real carbon removal done.